lastly today, we're going to tackle an object on a slope. Usually, when we find the components of a force, we find the vertical and horizontal components. But you can find any components you like, as long as the two directions are perpendicular to each other. If you have an object on a slope, the two other forces you've definitely got acting are the normal contact force, which acts perpendicular to the slope, and the friction, which acts parallel to the slope. So it makes much more sense to split the W into a component in the direction of N and another one in the direction of F than it does to split both of those two up into vertical and horizontal. So that's what we're going to do. Here is the component in the direction of N, and there's friction, so here is parallel to the slope, here is the component parallel to the slope in the direction of F. Right then, so I'm going to label this one W perpendicular to the slope, and that one W parallel to the slope. And I would say it's always worth drawing it a bit bigger somewhere else on the page, otherwise it's always very crammed in. Right, very, very careful with the angles now. The whole point, remember, of these directions is that they're perpendicular to each other. So the right angle goes there. And now for the other angle, you can convince yourself of this with a bit of geometry, but this angle here is that angle there. Now, I always think the quick and easy way to do this is just draw your slope very, very shallow. And then you get a very skinny triangle, and it's easy to see this angle must be the 5 degrees. It can't be that one. So I would suggest just draw a very shallow ramp, and then you know that the skinny angle is this angle down here. It's obvious. All right. So if these forces, the three forces add up to 0, then I know that N must be cancelled out by this component, which is this one here. So I get N equals W cos 5 degrees, and friction must be cancelled out by this component here. So I get friction equals W sine 5 degrees, which you weren't able to see because I'd moved it up. And so last thing for today, here's an example question. You're not going to have to balance forces here, you're just being asked to find the components of the weight perpendicular and parallel to the windscreen. Okay, so I've redrawn my diagram here with a much skinnier slope to help me spot the angles correctly. So now I want a component of W that's in the same direction as R, which is perpendicular to the slope. And then I want a component that's parallel to F, which is parallel to the slope. There we go. And so now, nice and easy to see that this angle, which is 30 degrees, is that one there, the skinny one at the top. Now drawing it again much bigger, you can never have too many diagrams. That narrow angle at the top there was our 30. And remember, the whole point of this question is that this direction and this direction are perpendicular to each other. So that's your right angle. Now we do our trig, which gives us this.